Okay, so let's have a look at alpha, beta minus, beta positive, and gamma decay in a little bit more detail. So some of you will be wondering what makes something stable and what makes something unstable. So for example, with carbon 12, carbon 12 is stable. The amount of protons is equal to the amount of neutrons, because 12 taken away 6 is 6. Carbon 14 is unstable, and it's a beta negative emitter. But why? What determines this? It's all determined by the stability line graph. Now, if you go onto any search engine and type in the NZ line graph or the stability line graph for radioactivity and go to image search, you will get this lovely diagram. So what's going on? Here, this is the number of neutrons. This is the number of protons. Now, here you can see that if we have n equal to z and do that as a straight line, the stability line actually starts to deviate relatively early on, about n equals to 10 and z equals to 10 round about here. I've deviated too early on this, please forgive me. So, if something is radioactive, it is because it has got too many neutrons, too many protons, it is too heavy, or it has too much energy. So let's investigate. Okay, for beta negative to occur, a neutron must change into a proton through the weak interaction when the weak nuclear bonds. So if something's got too many neutrons, it will emit beta negative. Too many neutrons are things that are higher than the stability line. If it's got too many protons, it's proton rich. A proton changes into a neutron via the weak interaction, and this is beta positive. These are things below the stability line. Please note, okay, that these dots are below the stability line rather than the n equals z line. If it's too heavy, such as certain isotopes of uranium, okay, then it'll emit alpha, and that's because it gets rid of 4 nucleons in one go, as it is a helium nucleus, so it is the most likely to decrease the mass. How do we plot the stability line? Okay, up until n equals 10, z equals 10, it is a straight line, and then it starts to curve upwards. For an accurate stability line, you are aiming for when the neutrons are in between 115 and 125, okay, z is equal to 80, z being the proton number. This does not include gamma. Gamma is not a mass emission, it is the emission of an electromagnetic wave. So let's say that we've got cobalt 60. Cobalt 60 is a beta negative emitter. So that forms a new element, which is nickel, okay, and nickel 60 forms in the metastable state. Now what I mean by that is, when it's formed, it's already excited. In terms of quantum energy and quantum phenomena, it forms in a higher energy level than the ground state. For it to get to the ground state, it needs to emit a gamma photon. And it does emit that gamma photon to go to the ground state. This is how radiotherapy works. What happens is you get metastable technetium emitting gamma photons, and that is what goes into your radiotherapy unit. You can chart how an element changes into another element over time. Okay, so for example, if you're wondering what thorium does all the way down to its final element when it stops decaying, you can plot a series of links and find out what it ends up as. If you are interested in this, use a search engine to have a look at decay mode charts. When we've got an NZ chart, if it emits an alpha particle, it emits 2 neutrons and 2 protons. So it is a diagonal translational shift by 2 and 2. If it's beta negative, okay, that's an increase of a proton number because the neutron has changed into a proton. The neutron number goes down by 1 and the proton number goes up by 1. So it's a diagonal shift plus 1 to the right. Conversely, for beta positive is when the proton changes into a neutron. So the proton number goes down by 1, but the neutron number has gone up. Be careful. If you are given a nucleon against proton chart, an AZ chart, then alpha is a mass release of 4. So it's a nucleon decrease of 4, but the proton number decreases by 2. The mass number does not change for beta and negative, so the nucleon number doesn't change, and that's represented by a sideways shift. It's the proton number that changes. For more information, have a look at detailed decay mode charts. Thank you.